Okay, I want to end this discussion today by talking a little bit about that last reading I asked you to do on the prisoner's dilemma and the lessons for morality in politics that Resnick discusses at the end of that last reading. And one of the things you confronted in that last reading was this no doubt confusing decision game chart tree that talks about the situation involving your choice to basically either cheat or to cooperate. Okay? You have two options. You can either become a cheater or become a cooperator. And now consider it from a decision game theoretic perspective. If you become a cheater, that is, you're trying to cheat people, cheat others, you will then either meet another cheater, the probability of meeting a cooperator being P, the probability of meeting a cheater being 1 minus P. If you're a cheater and you meet another cheater, you both will fail to exploit each other. You're both attempting to cheat, and the outcome will be the value U of no cooperation and no exploitation on your interval preference scale. On the other hand, if you become a cheater and you meet a cooperator, probability of doing that is P. You will then attempt to exploit that cooperator. There will be some probability Q of you successfully exploiting. If you meet a cooperator and exploit that cooperator, you get the payoff you want the payoff of successfully exploiting somebody else, successfully cheating, the most preferred item on your list because it has the highest payoff. On the other hand, if you meet a cooperator, probability P, but you fail to exploit, probability 1 minus Q, you're back to U, no cooperation, no exploitation, U. If you become a cooperator, you'll either meet a cheater or meet a cooperator. If you meet another cooperator, again, the probability of that happening is P, because that's the probability that the next person you meet is a cooperator. You will either successfully cooperate, R, with a utility value of U prime, your second most preferred outcome of successfully cooperating and splitting the joint payoff of your successful cooperation, or you'll meet another cooperator, probability P. You will fail to cooperate successfully, 1 minus R, and you'll just be back at U, no cooperation, no exploitation, no change. On the other hand, if you're a cooperator and you meet a cheater, probability 1 minus P, you will either avoid being exploited, probability 1 minus Q, in which case you're back at U, no cooperation, no exploitation, or if you meet another cheater, you will get exploited, probability Q, utility there of 0, your least preferred outcome, where you are cheated and your resources are removed from you by the person cheating. So we have all the possible outcomes with all the probabilities of you becoming a cheater or becoming a cooperator. And as you look at this from a game theoretic perspective, you can calculate the expected value of each of these possible moves. And you can then act on the action as a rational, self-interested agent that has the highest expected utility of all these particular probabilities and utilities. And in typical situations, you will probably find, depending on what these particular values are, that it can sometimes be in your interest to become a cheater, become an exploiter, and that's what creates the prisoner's dilemma. The rational motive to exploit another for your own rational self-interest and leave that other person with their worst outcome, but from your perspective, you getting your best outcome. That's exactly what the prisoner's dilemma is. If you go back, getting that payoff in the original prisoner's dilemma of -1, right, as opposed to the payoff of minus 10, which is if you both cooperate. But if you could, of you both failing, right? But if you could somehow figure out that strategy to which you could both cooperate, you will do not quite as well as successfully exploiting, -2 in the original prison dilemma instead of -1. But by both of you taking the exploitation strategy, you tend to wind up here, that value of u, the minus 10, as opposed to the 0, the minus 25. This is the basic structure that confronts you with regard to the choice of whether or not to cheat or whether or not to cooperate on any kind of game theoretic situation involving a population of cheaters and cooperators, probabilities of successfully exploiting, successfully cooperating, and the utilities of these payoffs.